Hello, everyone. I'm very excited to welcome Dr. Shankadeep Chakraborty in
Hi.
our problem solving session today. We are trying out the problems from ISI BStat BMath Entrance 2022. Shankadeep will be solving some of the problems with us. We will start with problem number 19. So, Shankadeep, fire away.
Fine. So this is a very typically algebra problem, equation solving problem. But instead of assuming one variable, if you assume two, then the calculation is greatly simplified. So we are
Okay.
supposed to find the sum. So it says the column sum, but column sum is the same as row sum is the same as diagonal sum. Let us
So that
assume,
is that is what a magic square is, right? That
yes.
the sum of the numbers in the columns and the sum of the numbers in the rows and the sum of the numbers in the diagonal are all same. Okay. Okay.
So let that number be S.
Maybe we can have a little bit darker color. Can we do
Yes.
that?
What
Yeah.
I think now it's better, right? So
Yeah.
let that number be S, and I will also be assuming an extra variable which is X. Now
Okay.
one might ask, we are supposed to find one variable. If we introduce two variables, how can we solve it? It's because we are going to get two equations in two variables. In the end, we will be able to get rid of one of them. We can
Okay.
also try to do it with one variable, just one variable, but that will be much more complicated. So let's not do that.
Okay.
So this one here is going to be S minus 58. Why is that? Because the sum is 27 plus something plus 31. The sum of 27 and 31 is 58. So that thing is S minus 58.
So
For the,
S is the sum of the rows or sum of the
yes,
constant, right?
the
Okay. I
constant.
see.
The variable we are after, that is S. The
S
quantity
is
we
the
are after,
variable.
the
So our
quantity is
goal
that.
is S. Our goal is
Yes, our
S.
goal
Okay.
is S.
Got it.
This one here is S minus X minus 31.
Okay.
This one is S minus 63 for similar reasons.
Uh-huh.
So now combining these two, this one turns out to be 94 plus X minus S. And the
Okay.
one in the middle is seen to be S minus X minus 36. Now we are going to use the diagonals. So the sum of the first diagonal is 27 plus S minus X minus 36 plus S minus X minus 31. And S. I'm talking about this diagonal here. Okay. And the sum of the other diagonals is 31 plus S minus X minus 36 plus S minus 63. And that is equal to S again.
Okay.
So we can simplify the first one to get S minus 2x is equal to 40 and S minus x is equal to 68.
Okay, so we have two equations in two variables. Okay.
Yes, so clearly it's the solution is very easy from here. Actually, we can multiply the second one by 2 and we get 2s minus 2x is equal to 136.
Right.
And then we take the difference and that gives us s. S is equal to 96.
Okay, fantastic. So this is a simple algebra sort type of equation problem. So nothing complicated here. That's great. Let's go to the next one.
Okay. So this is a problem where a little some knowledge of congruence. I mean the modular arithmetic notation greatly simplifies the problem. Okay.
Okay.
Note that 2022 is congruent to 6 modulo 7.
Uh, so
Okay.
basically, if I divide 2022 by 7, then the remainder will be 6.
Yes, because it's actually 288 times
Uh-huh.
7 plus 6.
Oh, okay. That's
Okay.
great.
That means let's call this quantity Fn.
Okay.
Therefore, Fn is congruent to n power 5 plus 4n power 4 plus 3n cube uh, congruent to plus 6 modulo 7. This is
Okay.
the first simplification. We got rid of 2022, which is clearly clearly a reference to the year we are in. It has no real significance apart from
Right.
that.
Uh-huh.
Now it became plus 6. The second thing is to factorize this. It's not really necessary, but we'll do it anyway. So factorize this here. And
Okay.
that's actually n cubed times n plus 1 times n plus 3
Okay.
plus 6 modulo 7.
Okay.
And now you just need to check the different possible residues. N can be congruent to 0, plus minus 1, or plus minus 2, or plus minus 3 modulo 7.
Right.
Okay. And you have to try each of them and see which ones work. The only ones that are going to work are, okay, let me check here. They're going to be 1 and plus minus 2.
Okay.
So this actually we're trying to set this congruent to 0, right? So we want Fn congruent to 0 mod 7.
Right. We want the remainder to be 0
0,
because we
yes,
want 7 to divide it. Okay.
exactly. And we put each n here, 0 plus minus 1 plus minus 2 plus minus 3, and we check which ones work. So it's a
Okay.
somewhat long calculation, but you will see that the only ones that work are n congruent to 1 and plus minus 2. And minus 2
Okay.
is actually 5. Okay, so
Right.
it's 1, 2, 5, 1 to 5.
Okay.
That means the permissible numbers in the range are first the ones that are congruent to 1, that are 1, 8, 15,
22. 15, 22. Yeah.
22. Then it's 2, 9, 17. No, 16, right?
Right.
16.
16.
16. Then just that, nothing else.
Right.
Then
And then
5,
we have,
5,
yeah. Right.
19,
12. Mhm.
5, 12, yes, 12 and 19.
So we got all the numbers in that range that set. If we plug in n equal to that, we will be able to
Yes.
get a number that is divisible by 7. Okay. That's
So that
nice.
answer is 10.
Okay. Fantastic. Let's proceed to the next one.
Next one. So this is a problem where notation greatly simplifies the problem. When I see a problem like this, I remember Feynman, who once said that mathematics is a search for better notation. Okay. So This is a problem which is like that. So suppose the
Okay.
number of students that know that are able to write with the right hand is the set of students actually is R,
Okay.
and the set of students that are able to write with the left hand is L. Then the problem actually tells you a number of things,
Okay.
which is
So can we just quickly say what the problem says? So in a class of 45 students, 3 students can write well using either hand. Okay. So number of students who can write well only with the right hand is 24, and only with the left hand, uh, 24
no,
more
it's
than.
about 24
Oh, I
more than.
see. I
Okay.
see. I see. So R. Okay, I see. Then the number of students who can write well with the right hand is like a Venn diagram problem. I see.
Yes, yes. So I define the sets. R is the set of students that can write with the right hand, and L is the set of students that can write with the left hand.
Okay.
And obviously, we assume that all of them can write because they're students in
Yeah.
a class.
Let's
So
assume that. Yeah.
let's assume that. That means R union L has 45 elements. And
Correct.
that is also our universal set. Okay,
Yes. Yes.
remember that. That is also our
Everything. Yeah.
yes, that is also our universal set. Three
Right.
students can write using both hands. That means
Right.
R intersection L has cardinality 3
Correct.
only with right hand. That
Uh-huh.
is that means in language of set theory, that is R intersection L complement.
Right.
That is 24 more than the number who write with only left hand. So that is L intersection R complement.
Right.
Fine. So we have basically interpreted everything in terms of sets.
Right.
Now let's do some calculations. Now R intersection L complement is equal to R complement intersection L complement is equal to R complement union L whole complement, which is 45 minus R complement union L. So I'm not saying cardinality many times. Okay.
Yeah. Yeah. Of course.
Okay. And then we can break this up, which is R complement plus L minus
My
R complement intersection L.
like the De Morgan's law, sort of. Yeah.
Yes. So it's then we can rewrite it again. R complement intersection L plus 45 minus R complement plus L. Okay.
Okay.
I think we need to go to another board.
Okay.
Fine, I will go to another board. But before we do that, note that this is similar to uh, we can combine with this with this equation here, because on both sides we will have L intersection R complement. Then we'll be able to cancel the L intersection R complement.
Right.
Okay. And note further that 45 minus R complement is R, because 45 is the total number.
Right.
Okay. Now we'll go on to some other board. So it will give us 24 is equal to R minus L, I think. Yes, sorry, I wrote it wrong. It's R minus L here. Also, R plus L is R union L plus R intersection L.
Right.
And that is 45 plus 3. which is 48.
Let's say, yeah, 48.
Therefore, adding the two equations, I get R is equal to 48 plus 24 by 2, 72 by 2, which is
That's 30.
36. And that's what we were looking for.
So is it, I'm just asking that, is it possible to like do this just using the Venn diagram strategy?
Should be possible.
Maybe, right? Because you can just draw the picture and sort of do the same thing. Okay, let's proceed to the next one. Thus 22.
Fine. Note that omega cube is
Yeah,
equal to 1. So whenever
so it's
we
a
have
cube root of unity. Okay, yeah,
yes. So whenever we have a higher power, we can just divide the exponent by 3 and take the remainder.
right,
Omega power 3k plus 1 is omega. Omega power 3k plus 2 is omega square. And omega
right,
power 3k is 1.
right,
Okay. So everything depends upon division by 2. Now,
right,
2 power k, 2 is congruent to minus 1 mod 3.
right,
So 2 power k is congruent to minus 1 power k mod 3,
right,
which is 1 when k is even, which is
right,
2 when k is odd.
right,
So you are going to alternatively get terms like here, you will get terms like this: 1 minus omega plus omega square
right,
is 1 minus omega square plus omega. Then again,
right.
1 minus omega plus omega square, then 1 minus omega square plus omega. You will get just this, like alternatively.
Because omega to the power 2 square would be simply omega to the power 1, right? So
Yes,
that's simplification that you're doing. Yeah.
yes. So
Right.
you will using this simplification, you will keep getting the same thing over and over again. Okay.
Okay.
And how many terms are there? There are 5 of each,
Right.
because
Right.
it starts with 2 power 1 here and it goes till 2 power 10 here. That's why there are
Right.
10 terms and 5 of each.
5 of each type. Yes.
5 of each type. So this one actually simplifies to minus 2 omega. Why? Because omega square plus omega plus omega equal to 0.
Right.
So we add an omega, we subtract an omega, and we get this equal to minus 2 omega. Similarly, here we add an omega square, we subtract an omega square, we get minus 2 omega square. So finally, the product is going to be minus 2 omega power 5 times minus 2 omega square times 5. And
So this
you can,
omega and omega square will sort of multiply to get 1, right?
yes,
Yeah.
yes, they will multiply to get 1, and we'll be left with 2 power 10.
Fantastic. That's the correct answer. All right.
29. Okay.
Yeah.
So what we are going to do is, clearly the denominator almost looks like a multiple of the numerator, right? Almost, not exactly.
So we want to
Actually,
find out the domain.
I think this part is not there, right? Because it does not
Oh,
make
this
any
is an
sense.
this is an error. Okay, yeah. This is a
This is an
typo.
error. Yeah,
Yeah.
this does not make any sense.
Okay. So we want to find the range of this particular function. Okay.
And the clue is to know that the denominator looks almost like the twice of the numerator.
Oh,
So what we do is we write the numerator as x square x square plus 2x plus 4.5 minus 0.5.
Okay.
And then it's 2 times this.
Right.
Therefore, it simplifies to half minus 1 by 2 times the denominator. Okay.
Right.
Now I will again go to another board here. So half minus 1 by 2 times 2x squared plus 4x plus 9.
Right.
There are more things to observe actually. So 2x squared plus 4x plus 9 can be written as 2 into x squared plus 2x plus 1 plus 7.
Okay. So this is always positive
Yes, 2 into x plus 1 whole square plus 7.
because it's a
Therefore,
perfect square times something positive plus something positive. So this quantity is always positive. In fact,
it's
the
greater than
smallest it
equal to
can go is
7.
7. Right. Because when x equals to -1, that's when it is the largest, like smallest, sorry, smallest, yeah.
Therefore, the reciprocal
Mm-hmm.
for x plus 9 is less than equal to 1 by 7 and greater than
Right.
0.
Right.
Then we can multiply by 2 here
Uh-huh.
to get 14.
Okay.
Then we can take a negative that reverses the signs.
Reverses the inequality, yes.
Yes.
And then we add a half. Right.
We add a half. And that's, I think that thing is called fx, right?
Right.
Okay. That means half is greater than fx greater than equal to half minus 1 by 14, which is 3 by 7.
Solves
So
the problem.
yes, range of f is 0 open interval because 0 cannot be reached. Oh, sorry, half. Sorry,
Half. Half.
half. Because half, 3 by
It
7
cannot
is
go to
greater.
0. Yeah.
Yeah, 3 by 7 is less than half, actually. So it's the other way around. So its range is 3 by 7 closed, half open.
Right. Fantastic. So that's great. Thank you for your time, Shankadip, today.
You're welcome.
Wow. And I'm also excited about the math adda that we are doing. By the way, for the viewers, you can check the link in the description for the other problems from ISI and CMI entrance this year. Sorry, ISI BStat BMath entrance this year. We are also uploading the solutions. If you have your ideas, please put it in the comment section. You may have a better solution idea, so we'll be very interested to know your ideas as well. Thank you for joining in today. Bye.
Bye bye.
Bye.